Hi, I welcome all of you in my channel and in this video, and today I'm going to solve a two sample f-test with two tails. F-test is used when we have two variances and we want to check whether these variances are equal or not. I have picked question number 2.27 from the book Design and Analysis of Experiments written by Montgomery and 9th edition. The part A and B has been already solved in my previous video. The part A is based upon t-test, whereas part C is related to the f-test. So in this question we have two levels of C to F6. The levels are 125 and 200. 6 observations have been collected at each level, and now we want to check in the question that whether, now based upon the question statement, does C to F6 flow rate affect the wafer to wafer variability in H uniformity? H uniformity is my response variable, and these are 6 observations of the H uniformity in the samples. The word variability, it tells us that we have to check the variance of the two samples, and when we have two samples variances, we will always use the f-test. Let's start this question by formulating the hypothesis, then test statistic. After that we will select the rejection criteria that suits to our case, and based upon the results of the rejection criteria we will take our decision either to accept the null hypothesis or reject the null hypothesis. And by the end of the question we will write our reports based upon our that comprises our conclusions and findings. The null hypothesis is represented by H naught, and it says that sample 1 variance sigma 1 square is equal to sample 2 variance sigma 2 square. We will always keep the equality symbol in the null hypothesis, and the statement that we want to prove we always keep that in the alternate hypothesis. So in this case we said that both of the variances are not equal to each other. The symbol of greater than, smaller than, or unequal, these three symbols are always be kept in the alternate hypothesis. There is no equality sign ever in the alternate hypothesis. The test statistic is quite easy. We will divide sigma 1 square by sigma 2 square. Now I will calculate the variance for both samples. The formula for the variance is quite simple. We will have to subtract xi, means each individual value from its mean. We will take the square of that answer, and then we will take the sum of all those values. Just like you can say, we have this data. So I will subtract 2.7 minus mean, 4.6 minus mean, again 2.6 minus mean, and then till 3.0 minus mean till the last value. If we write in this way all of the values, it's too much time consuming. So the standard way of writing is that you write the first two values and then write a plus sign, then 3 dots. This is the standard way. Then again plus, and then the last value. These plus signs and these dots show the continuation, that all of the values have been included in the calculations. Similarly, for these 6 values of the sample 2 has been solved in the similar way in order to calculate the variance of the sample 2. Now f naught has been calculated and we got 0.86 as the f naught value. So my S1 was there, 0.577, and 0.674 was my S2. Now we will talk about the rejection criteria. The rejection criteria that is associated with our case, this is the first one. These are the two rejection criteria, and I have picked these rejection criteria from the book Design and Analysis of Experiments by Montgomery. I have copied those rejection criteria. In order to solve this part, rejection criteria, I strongly recommended you people to draw the figure of the F distribution. It will help you a lot. Before finding the critical values, I have taken alpha is equal to 0.055 or 5% as the significance level. So doing so, I got alpha by 2 value is equal to 0.025. Why I divided it by 2? Because I have two tail test. Look at the hypothesis of two tails. So we have to divide this alpha value by 2. So these were my two rejection criteria when I put the values. So alpha by 2, 0.0556 are the observation and of the numerator, and 6 are again the observation for the denominator variance. We got f 0.025, 5, 5. I will check this value in the F distribution table. In contrast, we have 2.5% probability of the rejection region on the right tail, whereas we will mark our critical region at the probability of 0.975 or 97.5, this one. So these are red shaded region are my rejection regions, whereas this greenish shaded region is my acceptable or good region. We have many F distribution tables by the end of your book, and this you have to select your desired F distribution table with the help of this probability value. So in this case we have this table with 0.025 alpha value. We have 2 degree of freedom V1 and V2. V1 is the degree of freedom that is associated with the numerator variance, whereas V2 is the degree of freedom that is associated with the denominator variance. We have 5 degree of freedom for the numerator, as well as we have 5 degree of freedom for the denominator. So based upon this information, we got that our cutoff value comes out to be 7.15. Now in order to calculate the value at the left tail, we just simply divide the value that we have obtained for the 2.5%. If we divide like 1.1 divided by 7.15, we will get let me calculate it. So we got our cutoff regions. One of my cutoff region is 0.139 and the second one is 7.15. So if our value lies in between these two values, or it lies in the good region, then we fail to reject the null hypothesis. So you can see that my F naught value or statistic value is 0.86, that lies in the good region, and based upon this we will make our decision. Before going towards the decision, we will have to check these two rejection criteria. So first of all, F naught 0.86 is greater than 7.15. Is it okay or not? So it means it's false. This is not true. And for the second one, we will do like 0.86. My statistic value is less than 0.139, which is also, you can say, false. Both of them are false. So none of our rejection criteria are satisfied. Therefore, we will move towards our decision. Our decision will be fail to reject the null hypothesis. So now I will write the report based upon this whole test. So now we will write our report that contains the conclusion. A two-sample F test is performed to compare the variances of two samples. It is statistically found that there is no difference in the variances of both samples. And that's the end of this question. Hopefully you like this video. If you have any questions, you can ask those questions in the comments, as well as you can do WhatsApp to me and you can email me your problems. Please hit the like button, subscribe to my channel. Thanks for watching this video. Bye.